Hello again. We're now going to enter into another concept which is there on the Raspberry Pi. Say, for example, we already saw how to blink an LED, and also we saw how to control an LED using an input button. But for now, let's say, for example, if I want to vary the brightness of the LED, if I want to vary the intensity of light, which is going to be displayed from the LED, which means the current which is going to come to the LED from one of the pins needs to be constantly changing, right? So say, for example, currently at the LED which we saw in the last program, if you will have a look that's in Python 3, we had written a program for blink. So if I open the blinking, if you remember, pin number 7, right? Pin number 7, I had defined it as an output pin. And on that pin number 7, I had given an output of a high and a low. So high, low, high, low, high, low. I gave on pin number 7. But now I don't want to give just a high and then a low. No. I don't want to do that. I don't want to give high means high completely. I want to give varying voltage, or if I want to give a varying signal such that the intensity of light that is coming out from the LED would vary from low to high. That's what I want. So basically, I do not want to use my pin as a digital pin anymore, but as an analog output pin. That is what I want to use the PWM pins as. All right. So how do I do it, and how do I get to access this, and how do I get to use it? All right. We'll understand that in detail as we start up with the new concept of PWM. PWM comes to our rescue, which I would call it as pulse width modulation. Pulse width modulation, right? So say, for example, you need to visualize what I'm going to say now. All right. Let's say if you want to switch on and off a light, if you want to switch on and off an LED or a light which is there in your room, you have a switch. Okay. Switch on, off, on, off. When you make the switches on, the light glows. When you make the switches off, the light goes off, right? That is exactly what happens when we switch on and off an LED. But now, I want you to visualize something like this. Let's say, for example, you were given a fan to control. And, you want to vary the speed of the fan. But let's say, sadly, you were not given the regulator. The regulator to control the speed of the fan is not given to you. But you still have a switch. Okay, you're just given the switch, which is to switch off the fan, and which is to switch on the fan. That's it. But you are told to control the speed of the fan. How would you control it? How would you control the speed of the fan when you have to control using a switch? How would you do that? This is where you understand the concept of PWM. Let me say, for example, the minute I switch off the fan button, okay, when I switch off the fan button, does the speed of the fan, does it become zero instantly? No, it does not become zero instantly. It goes down slow, and then it will become zero gradually, right? Now, what if when it becomes a bit slow, when it's become a bit slow, I make it on again? Then I don't allow it to go back to the fast state. I don't want it to go back to the fast state. If I keep switching it on and off, on and off, on and off, on and off in such a way, if I keep switching the fan button on and off in such a way that the fan speed is neither completely high nor is it completely low, can I say I have attained some control of speed of the fan? Yes, even though it's mechanically, I have attained to control the speed of the fan, or try to make it a bit less. The fan will neither be off nor will it be on, but it will be at a medium speed. It will be at a medium speed based on the number of times you switch on and off. Based on the number of times you switch on and off. If you switch it on for a longer time and off for a short time, then what will happen? The fan will be rotating at a higher speed. If you keep it off for a longer time and on for a short time, it will be rotating at a shorter speed, right? So you are basically varying the on time and the off time. Okay, so you're varying the on time and the off time. Now, this is exactly what pulse width modulation does. It fakes analog output in such a way that you give a pulse which is high and you give a pulse which is low very fast. You give one after the other on a same pin. So let's say if you have taken a particular pin, let's say one of the GPIO pins, of course not all GPIO pins give PWM, specifically 12, 18, 13 and 19. These are the ones which are used for PWM, 12, 18, 13 and 19. So these are the pins which are basically used for pulse width modulation. Okay, coming to that a bit later. But for now, let's say, for example, on this particular pin, instead of giving a high and instead of giving a low, what if I could do something like giving a high and low, giving a high, low, high, low, high, low, high, low, high, low at a very fast rate. Can you imagine the voltage which comes out from that particular pin? Let's say pin number 12. Pin number 12, I don't give a high from it, nor do I give a low from it, but I give a high, low, high, low, high, low, high, low, high, low, such that the voltage that is coming out from pin number 12 is no longer going to be neither maximum, nor is it going to be zero. It is going to be somewhere in between. And that is going to be varied by the width of the on time and the off time, right? So if the on time is more, then the voltage will be more closer to the maximum. If the off time is more, the voltage will be more close to the zero, right? So we need to vary the width of the pulses, hence known as pulse width modulation. Are you able to understand pulse width modulation? So we are now going to understand how to give a pulse width modulation signal on the Raspberry Pi. Alright, so we'll open a new file. We are going to save it. Let's save it as pulse width, right? Okay, and we are going to start writing a code for pulse width modulation. But before that, let's have a look at the pins. Which pins do we connect to? Alright, let's see which pin should I use. I had said pin number 12, 18, 13 and 19 were the ideal pins that can be used for pulse width modulation. 12, 18, and these are the GPIO pins, not the board numbering, but the Broadcom numbering. 12, 18, 13, 19. Let's have a look at where this pin configuration lies. So I'll just minimize my Raspberry Pi screen, which is running on my VNC. I'll just minimize this and I'm going to just see the Raspberry Pi pin configuration. So as you can see, the Raspberry Pi pin configuration I have from pin number 1 to pin number 40, right? So this is my pin 1, pin 2, pin 3, pin 4, pin 5, pin 6. Oh, pin 1, pin 2, pin 3, pin 4, pin 5, pin 6, pin 7, pin 8. Alright, but that's not the board, that's the board numbering, that's not the Broadcom numbering. I want to go for the Broadcom numbering where I need pin number, I said pin number 12, pin number 12, that is, pin number GPIO 12. GPIO 12, where is GPIO 12? GPIO 12 is this. GPIO 12, that is pin number, board number 32. That is GPIO pin. Then you have a GPIO 18. GPIO 18 is nothing but the board number 12 itself, right? Then you have another one that is GPIO 13. GPIO 13, that is 33, pin number 33. And then you have a GPIO 19, which is pin number 35. So this is more easier for us to, understand. Just 2 pins away from the last. The 2 pins away from the last. If this is 40, somewhere here, GPIO 19 is 35. So we'll go for GPIO 19 and we'll start programming in that particular fashion. All right, let's get back to our code. And here we are. Let's start coding on it. Okay, so we're going to use pin number 19. Now, what we're going to do is we need to generate the PWM using a Python code. All right, so we can do something like this: import. Of course, if you remember, I need to import the rpi.gpio library, and I'm going to use it as, let me say I'm going to use it as GPIO, a big one. right? I can import from time. I'm going to import sleep, right? Say, for example, whenever I want to cause a delay to happen, I can do that, right? Okay, so what I need to do is I need to say, GPIO.setMode. I need to say which pin mode am I using? Am I using the GPIO board, or am I using the Broadcom configuration? Let's use the Broadcom configuration, that is GPIO.BCM Broadcom, right? .Broadcom, where I'm going to use pin number 19, GPIO 19 to be specific. All right, so GPIO.Broadcom, and then I'm going to call the setup function, which is going to say pin number 19, right? That is GPIO.Broadcom configuration pin number. That is 19, that is GPIO 19. You need to act as an output pin. Of course, you're giving an output, where it is going to vary. You need to act as an output pin. All right. Now, this much is already understood. We had understood it last lecture itself. All right. Now we need to go for something like, after set mode and after doing set up, we need to create a PWM object. We need to create a PWM object. That's what we need to do, right?